Hi, everybody. Welcome to this quarter's This.JavaScript. I'm very excited to introduce a few of our speakers. We have Addy Osmani here from the Chrome team. Hi, Addy.
Hello.
We have Brendan Eich from Brave. Ooh. Whoa.
Hi.
I was watching the screen thing as I was introducing people. So anyways, we have Brendan from Brave, and then we also have Nolan Lawson from the Eich team, Sashko from Apollo GraphQL, and we have Matt Claypotch from Mozilla, and we have Sean Larkin from Webpack. So welcome, guys.
What's up?
So one of the reasons why we do this .JavaScript, we do this on a quarterly basis. We'll be featuring browsers and other non-framework specific technologies every 6 months, and then we feature last quarter we featured a bunch of the different frameworks and libraries. So what we're hoping is that as you guys are watching this, you guys have the opportunity to figure out what's going on, what's the latest. There might not be anything big and amazing every single quarter that's announced, but that's sort of the point, right? That it's really great for everybody to be able to see incremental progress of the different frameworks, browsers, libraries, just what's happening in JavaScript, and hopefully inspire you guys to take advantage of the latest technologies and get involved within the JavaScript community. So you can find all these people on Twitter. My name's Lady Lite. You can follow me on Twitter at Lady Lite as well. I'm the co-founder of a company called This.Labs and This.Media. So if you're excited about things related to JavaScript, check out This.Media. We have a bunch of different awesome events and different things like that. And the format of this, it's going to be basically 10 minutes of everybody chatting about what's latest in their specific browsers or technologies. And we'll be having another one where all of these guys will be coming back and we can do an AMA. There's also a chat window open, so if you guys do have questions, feel free to join the chat window and we can ask those questions, but also remember that we are nice people here and to abide by a code of conduct. Okay, so with that, I will go ahead and introduce our first speaker, which is Addy from Chrome. You can take it away, Addy.
Hello. All right, let me kick off my screen share, see how well this works with QuickTime recording. And let's go. Cool. Can everybody see my slides? Tracy, are the slides showing up?
Yes.
Sorry, yes, they are. Oh, also, can you record your screen?
Yes, it's recording.
Thank you. Awesome. Perfect. We can see everything.
Cool. Awesome. All right. Hey, I'm Addy Osmani. I work on a few different bits and pieces in Chrome. I work on things like loading, performance, PWAs. I work over in Mountain View. Probably the best part of our office is that we have an offline dinosaur in the corner. Unfortunately, when the folks that were making this, constructing it, they decided to add an extra set of legs to the dinosaur. And as per last year, the Chrome team wanted me to let you know that the back legs have been deprecated. We just haven't removed them just yet, but we're working on it. It'll happen eventually. Last year was a big year for progressive web apps for us. There was a lot of focus around these apps that are sort of fast, engaging, and offer a deeper, more meaningful experience on mobile devices. And we saw a lot of good traction with PWAs. I think especially in emerging markets. 2017 has been a big year where progressive web apps are starting to go a lot more mainstream. We recently completed this collaboration with Twitter, getting out Twitter Lite, and I'll talk a little bit more about that in just a few minutes. Forbes also rolled out their new PWA for their mobile experience. And in other markets, we've seen large companies like Ola go all in on mobile web for their experiences, and they've been seeing good numbers off the back of that too. Now on the sort of JavaScript and API side, there are a few different changes we've been making to try making PWAs sort of a better first-class citizen on platforms like Android. So this year, we introduced the ability for PWAs to be more deeply integrated. So a PWA that is sort of passing all the check marks in Lighthouse will be able to get a presence in the application drawer next to the rest of your native apps. It'll be manageable like a native app is. You'll be able to go into the place where you normally control all of your native apps. You'll be able to see how much storage PWA is taking up. You'll be able to control like permissions and notifications and so on. And anytime you're looking for an app, the same places you look for a native app in Android, you'll also be able to find them there. Outside of that, now that's kind of huge because that's a platform with like over 1 billion users investing in trying to make web apps a first-class citizen there. But we've also been working on trying to improve our lower-level capabilities too. So we've been investing in trying to level up push notifications. Most recently, we started shipping Navigator Media Session, which gives you sort of media-based notifications. We also experimented with the Web Share API, which allows you to sort of call out to the share sheet. That's the sort of native Android share sheet for sharing URLs with other applications. We're just about wrapping up an origin trial on that. And we also ship support for display full screen, which gives you the ability to hide that bar at the very top of the screen that usually has sort of network information and battery information. So you have complete control over all of the real estate that's on your phone. Twitter, one of the most recent folks that experimented with Web Share. And the way that you use this is using the navigator.share API. You pass it an object containing sort of a title, text, and a URL. In Twitter's case, they decided to sort of customize the UI. And when you'd end up sort of just calling share on it, it would go and it would show up that, that share sheet on Android. As I mentioned, the origin trial is just about wrapping up, and we're hopefully going to take on any feedback that we got during that to make sure that the API is exactly what folks want it to be. Outside of that, we've also been trying to improve the ability for folks to ship really complex media experiences on the web. In Chrome 57, we introduced the shape detection API. Now, this is great for allowing you, without having to sort of just handle this in client-side JavaScript entirely on your own using something like CCV, to detect shapes. So barcodes, detect faces, detect text in things like articles. And this is an API that's relatively convenient to use. It allows you to take advantage of the hardware acceleration that an actual device has instead of just trying to do a lot of this stuff on your own. Avoids you also having to ship down a library to do this. And Paul Kinlan has got a great article that talks about some of our capabilities there that I'd recommend folks go and check out. We've also introduced an intent to ship for the image capture API. For anyone that's tried, building Instagram-like capabilities on the web before, you've probably noticed that we've been lacking the ability to really take control of the camera and do things like control zoom and focus, resolution, get control over sort of ISO or the flash. And the media image capture API solves a lot of those use cases. So I'm looking forward to seeing that ship and whether there are any remaining gaps that we can fill in for people that are trying to build those types of rich camera experiences on the web too. The payment request API is something that we shipped in Chrome 53, and the idea here is that it gives you this native UI that makes checkout flow a lot easier. So you can select, you can add payments in a fast and consistent way using a sort of standardized imperative API. And we're starting to see people pick this up too. Just yesterday, we heard that Kogan.com, one of Australia's largest department stores, shipped support for payment request as well. And we're hoping to see an increased number of people trying this out and giving us feedback on how we can improve the overall UX flow and see if users actually enjoy this experience more than custom sort of checkout flows they have at the moment. I'm going to talk about performance real quick. I care a lot about performance. I'm going to focus very quickly on V8. So on the V8 side in the past, we've used different sets of benchmarks for optimizing. Octane is probably one of the ones that we're better known for optimizing against. And that was a benchmark that sort of stressed peak performance. But over the last year or two, we've noticed that the optimizations we would get out of Octane didn't always represent optimizations that would help real-world web apps. So if you're someone that's building apps using like React or Ember or Angular or any of those things, Octane performance wins didn't always result in the same type of wins we'd hope to see with those types of applications. But we noticed that other benchmarks like Speedometer did. And so we've been putting in a lot of work trying to optimize for real-world workloads across actual pages that people are using. So things like sites that are in the top 25 on the web, like Facebook and Wikipedia and so on. This is a breakdown of sort of where time is spent in JavaScript. So Octane at the very top spent quite a lot of time in just JavaScript itself. Speedometer is a benchmark that sort of stress tests framework code. And what we noticed there was that a lot more time is spent in things like runtime and parsing. And real-world workloads actually happen to spend a lot more time in parsing and compilation than we thought. So we're working on trying to make things like parsing a lot faster so that pages can start up quicker than they do today. Some quick wins that we've seen there over the last 6 to 12 months. We've seen a 30% increase in our performance on real-world sites, 14% wins on framework application performance. So between 14 and 30 are roughly the numbers there. We saw a 7% reduction in the time blocking the main threads with JavaScript execution, thanks to our new compiler pipeline, which is powered by Ignition and Turbofan. We've got a few blog posts on that. We're edging closer to parity on our ES 2015 performance compared to ES 5. We're still a few percentage off in a few places, but for a lot of different classes of applications, this should actually be fine. If you're someone using Babel, I actually highly recommend checking out Babel's preset env so that you're only transpiling code that your browser doesn't support. We're also heavily working in progress on our modules implementation and our dynamic import implementation, and we hope to see a little bit more to share there around Chrome 59 or Chrome 60. Now, we know that the mobile web can be slow for a number of reasons. People tend to ship down a lot more JavaScript than they need. They tend to ship down, images that are too large, paint storms. A lot of things can end up causing experiences on mobile devices to be subpar. We've got constraints on CPU and battery and memory and so on. But that hasn't sort of stopped folks like Twitter actually shipping relatively fast experiences that are really, really great on mobile devices, like average mobile devices as well, not just the high-end stuff. So Twitter Lite took advantage of the purple pattern that Polymer discovered last year. So they're taking advantage of Service Worker for pre-caching their static assets, as well as their application shell. They're taking advantage of preload for sort of increasing the priority of critical path JavaScript that they need to be loading early on. Breaking up their scripts. They're interactive in about 5 seconds on 3G, which is great. They're using the platform correctly, so they're deferring expensive rendering using request on a callback. They're using the platform for data savings. So they've got a great data saver mode in there where if you turn it on, it won't actually load the full image or the full animated GIFs or videos when you scroll through your timeline. It's completely up to you as a user, to say, well, hey, I do actually want to look at that animated GIF of the cat and pop it up. But Twitter didn't really get to that place without a little bit of work. Now on our side, the way that we ask people to check in on how well they're doing is using a tool called Lighthouse. And Twitter's initial app that they tried building this PWA with wasn't particularly fast. They had a time to interactive of about 15 seconds, which is based on our research about how long it takes for a lot of apps that are built using modern frameworks to get interactive on average hardware. And Twitter did a number of different things to sort of speed this up. One of the first things they did was breaking up their monolithic JavaScript bundles, like these really large bundles of code that weren't all needed when a user sort of landed on Twitter and started scrolling through their timeline. They broke that work up into what I believe ended up being sort of 30 or 40 different chunks across the entire experience. And this meant that they went from a very lengthy time to interactive score down to something that's a lot more manageable. This is their Lighthouse scores right after, where they were interactive at this point in time in under 6 seconds. They were eventually able to bring it down to something even lower than that. Now, I just wanted to show you some really quick demos of new stuff that we've landed in DevTools to help with the developer side of trimming down your bundles. So quick demos, if my system can manage QuickTime and Chrome and Canary and all these different things being open. So let's pop open that, and let's use mobile Twitter for this demo. So the first thing I'm going to show you is our code coverage feature, which we recently shipped in Canary. If you haven't noticed, we also added a new little What's New tab in Chrome 59. I believe it was Chrome 58, Chrome 59 that shows you what's new. But with code coverage, the basic idea is that I can say start recording this page. And it'll go and it'll check what JavaScript was actually being executed during this page load, and then it will process those different code paths, and it will show me directly inside of code coverage how much JavaScript I was and wasn't using. So here we can see we've got unused bytes being displayed. We've also got the total number of bytes, and these are all the different JavaScript bundles that Twitter have for their experience. And what we can see here is that it says that, you know, maybe only about half of the bundle that they were fetching was being used. Now that's great, but it doesn't give you sort of a completely nuanced picture. Maybe some of that code is being used across different views. So coverage also supports this other idea of point-in-time recording. So I can start recording here. I can go and I can reload this page, let it go and execute the different paths that it has to, and then I can navigate across different views. And I'm not going to turn on notifications just yet, but I can go and I can stop that. And I can see that more and more of that actual bundle was being used, which is great because it gives me a slightly more complete picture of the story. Code coverage also lets you see sort of CSS stats, depending on the type of application you're using. And this can be helpful for you understanding how many opportunities you have to further code split. So go check out code coverage. Something that we just shipped as well, so let's head over to the network panel, and for this I'm going to very quickly dive over to theverge.com. So as we can see, theverge.com is still loading up, and this is on Wi-Fi. This is like corporate Wi-Fi. It's really, really fast. It's still, you know, it's taking what, 12, 13 seconds to load up. If I had 3G network throttling enabled here, this would take a lot longer. So what we can do here now in the latest Canary is let's go and let's ignore product. Let's go to time and see what took the most time to actually load on this page. So we can see that there are some what appear to be beacon scripts, maybe from ads. We can see that there are some animated GIFs that took a while to load up, different third-party scripts. And what we've introduced is the ability for you to, sorry about that, we've introduced is the ability for you to select a request and actually block the request URL or block the request domain. So let's do that for some of these requests. Now, every single time that you do this, we're going to add it to this new panel down at the very bottom called request blocking. And what this panel allows you to do is basically investigate exactly what impact dropping a particular resource on your page is going to have on your critical path performance. So if I go and say, well, I know that I'm going to be running ads on my page, but I'm not entirely sure what vendors are sort of, you know, the worst actors in slowing down my performance, this feature can be really useful for understanding that. It's also useful for sort of just deciding, well, hey, do I really need that image header that I'm, you know, dropping in at the very top of my page, or other stuff that's lower down that the user may not find particularly useful. So in this case, they said that there's a 1 meg sized thing here. Let's go and say we've blocked that. I'm just going to reload the page really quickly. And what we should notice as we go through here, let's see, is that the page actually loaded just a little bit faster than it did before. So go check out request blocking. I'm really excited about this feature. I've been waiting a long time for it to land, and hopefully you'll find that useful. Very last thing for me is we also, so let's go to a quick progressive web app. I'm going to go to housing.com. And what I'm going to do here is let's actually try to load up the mobile experience. If you go to experiments, so DevTools, experiments, and you hit that shift thing to get the secret experiments, and you checkbox audits 2.0, one thing that you'll notice is that we've introduced, this is an early preview. Audits 2.0 is basically Lighthouse in DevTools. And the idea is that you can just go and run an audit, and it will go and basically do every single progressive web app and web platform best practice test that Lighthouse has. It'll go and run these a couple of times to collect all the different data around, you know, APIs you could be using to make this experience even faster. And what you'll see is that we get a Lighthouse report directly inside of DevTools. There's a lot of work being done to improve the overall experience of this, and this is, again, an early preview, but hopefully this is something folks will find useful. So let me go out of Canary, right back. So as I mentioned, one of the things that I work on is loading, and we've been talking a lot about that over on the reloading blog, so medium.com/reloading. If you're interested in checking some of that stuff out, please do. But That's otherwise it for me. We've got quite a few intents to ship out at the moment for everything from animated PNG support to long tasks and writable streams. But you can find out more at Google I/O in a few weeks or developers.google.com/web. So thank you.
Thanks, Addy. We had a few, actually, I think, which version of Android were you talking about? And will PWA be supported in iOS too?
So I'll answer the iOS question first. PWA is in iOS, so we don't necessarily control. I wish we had a little bit more say in that. We don't control what Apple ships. We have been seeing them continue investing in the web platform over on the Safari side. They've been shipping Fetch, and I know that things like link rel preload, etc., are currently in Safari Tech Preview. All we can do is just keep asking and say that this stuff is holding us back. We're trying to ship the best experiences for users that we can, and hope and pray that they they listen and eventually ship these features.
Very cool. Thank you. You can go ahead and stop recording your screen.
Yeah, thank you.
And you guys can follow Addy at Addy Osmani on Twitter. And I wanted to go ahead and introduce the next person, which is going to be Matt Claypotch. So.
Hello there. I'm going to start switching on my screen sharing and my recording and the whole party. 1 second. Okay. Make sure I've got my audio before I do that. Try that again, audio. Don't save. Screen recording. Avec audio. See, that's why. Cool. And present, starting with the first slide, ideally. Let that sweet hotel Wi-Fi trickle in. All right, starting my stopwatch. Hi, everyone. I am Potch, or Matt Claypotch. I am a developer advocate at Mozilla. Sort of, is developer relations plus a lot of feedback collection and going back and informing our priorities for web platform and Firefox features. I've been at Mozilla for about 7 years, and I'm going to give you a short update on what's going on in Firefox sort of as we get about a third of the way into our year. 2017 is a huge investment year for Mozilla in Firefox, particularly around Gecko, our rendering engine. Gecko has been around for a long time. Sort of predates many other browsers. It's just the rendering engine itself. And it's getting a little long on the tooth. So we've been undergoing a couple big multi-year projects that are really starting to bear fruit this year to completely update and revitalize the engine and make it ready for the next 10 to 12 years of browsers. So we're Mozilla. We're a nonprofit organization, and our goal really is to keep the internet healthy, open, and accessible to everyone. The way we do this is by making Firefox, as well as all kinds of extra advocacy work that we do sort of on the nonprofit side of our organization. So the big project for this year is Project Quantum. And what Project Quantum is an attempt, like I said, to really retrofit and modernize huge swaths of Gecko, the rendering engine in Firefox. The beginning piece of this started to land last year, where we moved to a multi-process architecture, which pays big dividends in terms of stability and security and performance. And now we're starting to actually make significant changes, not just to the architecture of our processes, but actually the individual rendering pipeline pieces in the browser. So how are we doing this? We have an experimental browser that we're working on called Servo. It's built using the language Rust, which is a Mozilla-sponsored project. And Rust tries to make parallel computing more safe by default, tries to include memory safety features out of the box. If it compiles, it has memory safety guarantees. And all of these things make it easier to write parallelized and concurrent code that it would be a big nightmare with a big hairball of C++ and C. So Servo is this, what if we started from first principles now and built a browser? And the answer is you can do a lot of things that really weren't feasible in the past, including taking advantage of all these awesome cores on our devices, right? Even our mobile phones now have multiple cores. Moore's law is sort of broken. And we need to start taking advantage of things beyond the single-threaded performance on the web. So there are a lot of ways to do that. We're focusing mostly on browser internals right now and not as much on the actual JavaScript execution. But the hope is by making the browser faster, we're making 10 louder, we can make it possible to take existing web code and just handle it more gracefully. And that hopefully gives developers like you more headroom to make high-performing websites. So one of the big pieces going to be landing this year is a project called Quantum Style. It comes from the observation that when styles change on a page, either due to animations or DOM updates or DOM insertions, those style computations can largely be computed in parallel. So we're actually going to start using multiple processes or multiple threads within a process to recompute style on the page in real time. This means two things. One, we can compute styles much, much faster. And on mobile devices, we can actually split the work up over threads and perhaps compute it at the same speed, thus requiring a little bit less clock power and actually reduce battery consumption for the same style computations. Quantum Style is expected to land in the next 2 to 3 months. And while you may not necessarily see big, huge performance leaps forward in your frame rates, hopefully with large batch DOM updates, you're going to see big improvements in how fast styles get applied. And hopefully the sort of recomputing style portions of your timelines are going to get a little smaller. And that's going to give you more headroom to make smooth online experiences. Another section is Quantum DOM. What this is actually doing is really going in and changing the way in which multiple browser tabs interact. So in addition to moving to multi-process models where 2 browser tabs can interact or can both run without interacting, we're also going to do some stuff just to overall reduce the sort of footprint on your computer and resource usage of Firefox. The big 3 pieces are prioritizing browser tasks. So most important ones run first. Those are responding to user input, handling in-page events on the front tab, all kinds of things that are going to be super performance critical for users in their real-time usage of your app. We're going to delay running code for background tabs. We're actually going to potentially start throttling tabs that are running in the background to make room for high priority foreground tab activities. I have to be very sensitive here. Obviously we don't want to disrupt music playing, if someone's listening to music in a background tab, but we do want to reduce the consumption of resources by background tabs. We've done a little research and determined that about 50% of background tab activity is tracking scripts, and I don't think anyone will be too sad if those get throttled a little bit. In addition, for things that are really slow, we may actually preempt them and say, OK, we're going to pause execution of this background task where it is, freeze it in space, and then jump over to our important foreground tasks and actually preempt that code and not even let it finish, but then pick it up where it left off. You have to do all these inter-process communication calls. And a lot of those, even though they're asynchronous, they're still ultimately blocking. You can't do anything until setting a cookie, for instance, is actually successful. So we're actually doing a ton of work to reduce and remove as many of these sort of synchronous IPC calls as possible. And we're really focusing on high complexity DOM-based, hyper optimizing those and sort of making sure that the most performance critical and most high use web applications run as smoothly as you would like them to. So what else are we doing? That's where I have more here. There we go, just a little laggy. So we in Firefox 52, we launched the initial implementation of WebAssembly. And WebAssembly, if you are not familiar, is the ability to take compiled languages such as like C, C++, and Rust, and a bunch of other languages that are, the long tail of languages, and run them into the LLVM compiler toolchain. And at the end, you output a compact binary format that is recognized by JavaScript engines. So we sort of redubbed our JavaScript engine really sort of a web VM, because in addition to running JavaScript, it now has this parallel pipeline for running WebAssembly code. This means high performance or super timing critical pieces of your application can be written in another language and compiled down and sort of running in this non-garbage collected high performance environment. Other browsers have already committed to or shipped implementations of WebAssembly. Chrome has shipped implementations of WebAssembly. I believe we have commitments from all the other major browsers that they are going to, if they haven't already. Forgive me if I haven't mentioned your browser and you have already shipped. It's going to, the big thing is we're going to unblock web games, right? No one needs to download the Unity plugin to run a game written in Unity because the game will actually compile down to WebAssembly. We have some existing tool chains that already do this. In addition, we're hoping framework authors will take the mission critical pieces of their application and perhaps write them in these compiled modules, which can call back and forth into user space JavaScript. So you can have a framework that maybe needs to do a complex diffing calculation on a static DOM tree or what have you, and we'll write that in compiled code and let that run, let that be called into by your DOM side operations. So you can go compute your important complicated diff very, very quickly and then jump back into JavaScript code to apply those changes. We also recently, in Firefox 52 in March, launched async functions and the await keyword. I'm going to go a little bit into these because I'm really excited about these. I think they really, really fundamentally change how we architect our JS code. For instance, here's sort of a common callback style workflow here. It's a little bit of a pyramid of doom, and I did that a little bit intentionally just to demonstrate what we're getting into right here. So we have a function where we're trying to get our user, and then if we get our user and there wasn't an error, we can go get the profile based on the user's ID. And then we can grab the profile and display it. Or if there's an error in a couple different places, we can catch that error and handle the error gracefully. So obviously, promises are part of ES6, and all browsers support them. So how would this look with promises? It's actually much, much more compact already. We're going to get a user, and we're going to wait for it to finish, have that .then, grab that user, and then continue down the chain by returning the get profile for the user ID, just like before. And at the end, we can catch all those errors and sort of pass them into our error handler. This is nice, but it still doesn't look like if you have been synchronous code. And I think the beauty of async functions and the await keyword is you can really sort of write async-looking code with very clear, easy to understand control flow, but actually make them be asynchronous under the hood. So we've got an async function now, and that async function can try the following two tasks. It can just do an assignment where we await the call to get user, and that's actually waiting for the promise underneath the hood to resolve. And then we can take that user object, and we can await getting the profile based on that information. And you can see you can just call functions, you can just do assignments, and wherever you drop that await keyword, we're actually going to pause execution of this function, go out and do the asynchronous task, and come back with the results. And if that promise rejects instead of resolves, we can catch that error using the catch keyword. You can actually, it's a little bit easier than worrying about you didn't either you'll catch it like this and you can handle the error, or it will actually end up becoming a throw. I know a lot of people are concerned about error handling in JS, and especially with promises, where promises don't really throw by default. And by using the await keyword, you are going to get a throw out of this. Now, granted, you'll have to catch it at the next outer layer, but it is sort of more familiar ergonomics for people who are familiar with the traditional synchronous JS flow. So just really quickly touching on WebVR. This is something that we've been working with other browser vendors, including Samsung, and we've been working with Chrome on this. And it's actually a small W3C community group working on VR. It's a set of JavaScript APIs that let you discover and interact with virtual reality hardware that's connected to your computer. We have support for the HTC Vive, working on support again for the Oculus and the Oculus Touch. And we just announced support that actually in Servo, we have experimental support for the Google Daydream headset, which is really exciting. And we're going to get that support actually back into mainline nightly Firefox as well. It's really, really cool to be able to make just a web page that can all of a sudden become this immersive experience. And that coupled with WebGL really lets you build these beautiful immersive worlds that can be delivered over a URL. I think the URL distribution model, even John Carmack has said, is the sort of the killer app for the web, right? I can click your link and be in your VR experience in seconds. It's a really, really fantastic experience, and we're looking forward to see what developers build with it. Speaking of WebGL, WebGL 2 shipped in the past quarter, and it's sort of an extension of WebGL 1. WebGL 1 was OpenGL ES2, and WebGL 2 was OpenGL ES3. the numbers don't line up, which sort of stinks. But what it means for developers is more modern shader features, more modern texture features, better particle support, and some additional optimizations that make your actual graphical computations and graphical renderings go a little bit faster. We have a bunch of demos out there. You can look up. If you look for WebGL2 demos online, this one is After the Flood. It's a really slick demo of sort of post-apocalyptic city with floating islands. I feel like floating islands are the sort of hello world of WebGL rendering demos, but this is no exception. And you should really check it out. If you're used to writing WebGL and you're comfortable, it's going to be just like a little bit of new stuff to understand. And we're hoping that JavaScript frameworks that wrap WebGL will start embracing these new WebGL2 features and just sort of abstract those away for users who are more familiar with a tool like Three.js. A couple other things to look forward to this year. We have the Tor uplift, which is actually sort of a project to take all that big hairy change set that is applied to the Firefox code base to make it into Tor, the anonymous browser, and actually uplift a lot of that code into Firefox and make it build time configuration. This is going to reduce the risk to the Tor project of having sort of at patch time introducing vulnerabilities and security issues that reduce the anonymity of the Tor browser. It also means that some of those cool privacy features like first-party isolation will actually be in Firefox, and we can start providing users with more privacy and security features that are sort of building on all the great work the Tor community has done. We're also committed to strong sandboxing on all platforms this year. We've moved to Sandbox Stage 2 on Windows. It's an extra bit of isolation, and we're going to have strong sandboxing up to Stage 3, as we call it. I know it's a bit jargony, but it means sort of modern, full-class tab browser process sandboxing. We want to make sure that our users are not at risk opening web pages on the internet. We want to make sure that our browser is not vulnerable to crashes when web pages go haywire. We've also got some web platform features. Webpayments API, I can say, is in progress. We have a group of people working on it right now. I don't have an estimated landing time for that, but I think we're really excited about web payment requests. And we think it makes e-commerce and sustainability for websites so much better that it's kind of a no-brainer to get implemented. And we've committed to shipping that, and it's in progress. Additionally, for WPAs, we actually have these PWAs, WPA security. PWAs, we actually now have add to home screen for on Firefox Android. What this means is if you're on a site that sort of has an app manifest and has a service worker, the user can be actually request to have that added to home screen. We haven't implemented all the heuristics for prompting, but users who know what they want can go add PWAs to the home screen on Firefox Android if they use Firefox. And additionally, this is not really a web platform feature, but we announced just about a week ago that we are going to be eliminating our Aurora release channel. What that means is right now Firefox has a 4-stage release process: nightly, Aurora, beta, and release. We're actually going to be removing Aurora. The hope with Aurora was to have about 10 times the users we would have had in nightly. Unfortunately, that never really reached fruition. So we're actually going to be focusing on more automated testing in nightly and concentrating a lot of our testing cohort of user testing in our beta channel. If you use Firefox Developer Edition, like I do, Firefox Developer Edition will now be based on the beta channel as opposed to the Aurora channel, so you can still expect that same experience. And we've taken the compact theme from Developer Edition and made it available just as a Firefox theme. So if you want a little bit more screen real estate from your browser, you can enable the compact light or dark themes. So all the goodness from the Aurora channel browser is now baked into Firefox across the board. And we're going to move from 18 weeks to a 16-week cycle or 12-week cycle. So new features are going to get to users faster. And lastly, I wanted to quick pitch web extensions. It's a sort of embracing of the Chrome model of browser extensions. We're actually trying to work with the other browsers to standardize web extensions, so you can really write one code base to extend browsers the same way you can write one standardized code base to build websites. This is still early work around the standardization process, but we have sort of announced that we have reached 98% Chrome parity, and there's great tool chains available, such as the web-x npm tool that will actually do a lint and tell you whether your existing Chrome extension code base will now work in Firefox. We're also adding a couple APIs for Firefox-specific features that aren't in other browsers, but we want to make sure that there's a big, nice, rock-solid, standard, common core that lets developers write one code base and deploy it across all of their users or all their browsers. I'm really excited about that because I love that model I love the worker model of building extensions, and I love the DevTools integration. So that's it. I am Potch on Twitter. If you have any other questions, you can ask them now or follow up with me later. So thank you so much.
Thank you so much. That was very awesome. People are very excited on the chat about the things that are launching and everything. I see some friends on chat. So you can also stop recording your screen if you like and go ahead and send that to me.
Will do.
And next up, I wanted to go ahead and introduce Brendan Eich, who's co-founder of Brave. Some of you may know him as the person who created JavaScript too. And yeah, we could round of applause. Sean's giving you a little bow right there. So go ahead and make sure to start recording your screen too. I think you're muted as well.
Yeah, I'm recording. Hi. So I had something for Addy first. If you can see that, maybe you can't until you're recording. You can stop trying to make fetch happen. It's happening. OK. I can't do Rachel McAdams. I'm sorry. I'm not blonde. I have a little deck on Brave because Brave's a different browser. It's fun to talk about, and I get to be different from just trying to keep up with all the cool dev tools and WebVR and such. It's awesome not to have to work in the salt mines of browser engines after 28-some years. You all work for me. One thing I'm excited about that's coming in, I hope this year, is finally getting some kind of better numeric type into JavaScript. So I've been working with Daniel Ehrenberg of Igalia, formerly the V8 team, who's the champion of the integer proposal in TC39. It's at stage 2. It is an arbitrary precision integer for JavaScript. You will use it conveniently with what we think will be the n suffix for the second letter of integer, because capital I doesn't work so well. And it's spelled integer, the constructor name, and it's kind of like the wrapper for IEEE doubles. It's called number, capital N. So it works like a sort of built-in primitive type with all the usual good affordances you need to actually use it, like operators. And one of the things that you will be relieved to hear is that it won't implicitly convert in lossy or crazy ways to double precision numbers. People have trouble in JavaScript because 0.1 plus 0.2 does not equal 0.3. The same is true in Java with doubles or C or any other language using the IEEE floating point standard, but I get all the blame for it because it's all my fault, just like Nans. So integers coming, that's got me excited because I think people are still struggling with the limits of floating point in JavaScript. Like I heard recently there was a Node API that reflects the Unix stat system call result, including the inode number. And people have huge file systems now, and apparently they have inode numbers, maybe they're sparse or something, that you need more than 53 bits of integer to count all the files in your file system. And so they're losing precision in JavaScript, and they're blaming me again, of course. So we're going to have integers sometime soon, I think. There's commitment to implement, and Igalia has talent to actually do some of the work for not only V8, but other engines like SpiderMonkey and JavaScript Core. OK, how do I share my screen? This is the part I didn't figure out. This is going to be me flailing.
It's on the top left. You'll see the green button that says screen share.
Oh, sweet. It's in the Hangout thing. Yes, nice. And I'm going to share my entire screen. You can see all my secrets. Is it working?
Not yet. I think you have to say share to everybody. There you go. Yep, works.
Yeah, no, it needed some special Chrome-only feature I'm using, I'm sure. Here, this is what I wanted to show. There you go. Fetch in Safari. Awesome. OK, integers you can read about on GitHub. All the TC39 work happens on GitHub. Things still take too long in standards, but at least they're on a yearly update cadence and with people like Dan, Little Dan on Twitter working hard on it, I think it'll happen. You can see even sort of a little Asm.js flavor of it. It's not that easy to use by hand if you're trying to keep everything in 64 bits. If you're just using big integers, you don't have to worry. They don't lose precision. They get as big as you want. Pretty good for machine learning and scientific stuff. OK. Let me talk about Brave. I think my joke about working in the browser salt mines, escaping, and then having you all work for me aside, I think there is a problem on the web that's at a higher level than DevTools or WASM or whatever. And it isn't really perceived as such because people don't connect their data plan. If they're on a tiered data plan, they don't connect the part that goes to ads and tracking to their bill. And I think Addy actually nicely showed a little bit in the DevTools waterfall there. You could see there were beacons for advertising or tracking. It's actually taking a lot of bandwidth. It takes a lot of time on the network, which means your smartphone radio is running, which is the #1 or #2 consumer of your battery. So you're losing battery life. So you're paying for it. You're actually paying for the internet because you're paying for your data that goes to trackers. Potch mentioned background tabs. Background tabs are doing insidious things like using web audio to sort of keep themselves alive, or possibly to do audio fingerprinting. I don't know. I'm very suspicious. There's all sorts of mischief there. Why should we run that stuff? When we did the web, made it commercial at Netscape, we had this sort of opinion about turning off things that were unsafe. We had to, integrate FTP and WACE and Gopher and HTTP. But at the end of the 90s, a lot of those were dying or dead. And it really was important, I think, at that point to protect users from things like pop-ups. Unfortunately, we didn't do a good job until Firefox, like 2003 or 4, maybe Mozilla before that. A few other browsers did it. And blocking pop-ups was this case of the browser being opinionated that actually worked. We stopped pop-up ads before they got too big, and we would have had huge commercial evil forces arrayed against us. But that didn't happen with other kinds of tracking ads. And so I think it's important for browsers to be opinionated about this stuff. I think it might be important to even have standards that address this, because right now it's kind of a mix across browsers, how you deal with things like pop-ups and ads. Pop-ups more or less have a consensus-based blocking, and maybe there's some standard in the W3C I haven't seen. But tracking is a mess. It's taking up all this time on the network, and you can see it on these sites. I think Boston.com is particularly egregious. I think they might have fixed it. But if you're paying half your bill for your data plan for tracking, something's wrong. And it's not really getting better because I think, having talked to publishers, including big ones, nobody wants to risk revenue. So ad blocking is the natural sort of immune response among users. If you get annoyed by all this cost, you get annoyed by a bad ad, and the ads are just the surface that's seen, they're sort of the tip of the iceberg, then you may get an ad blocker. And now you're really out of the whole ecosystem. You're now blocking ads, and if it's a good ad blocker, trackers everywhere, which means even sites that do a decent job or try to have good content and decent ads to make a living, make ends meet, are being punished. Seems like a problem. So with a great team, I built Brave to address this directly. So we're trying to not only block ads as a baseline, we're blocking trackers, pretty important. This means we are a lot faster. Like on Android, we're 3 to 6 times faster. On iOS, 3 to 7 times faster than the stock browser that does not block ads. And on Android, Chrome doesn't have an ad blocking extension API. You have to get a different browser. So you really need to get something that solves the problem deeply. It blocks the requests early. It's like the Hydra head. Didn't Hercules cut off the Hydra head and then burn the stump so it couldn't grow again? Otherwise, you kept getting more Hydra heads. That's what happens with the network waterfall with all these trackers, as I think Addy nicely demonstrated. Another way to look at it is the Ghostery D3 tracking graph. It's pretty fun, good use of D3 ball and stick physics. Kind of horrifying. This is TMZ. A lot of media sites do it. They've gone like crazy for third-party tracking and ad partners, so-called header bidding. They have like not only their own domain shards there, which is legit, but they have obviously DoubleClick and everybody else. It's almost like they went and said to the entire ad tech complex, partner with us, we'll add your tag to our page and slow it down even more. I didn't want to pick on The Verge, but Addy showed that too, and it's still slow on mobile. I mean, it's not getting better fast enough, and it's not really just the DOM's fault. It's ads and tracking. So with Brave, we put a shield up around the user. We show you the results of that shield, which really saves you time, blocks things, and we keep your data safe on your device, which is the only way to get bargaining power against all these people in the middle of the ecosystem, all the little balls there floating around you when you go to TMZ, for instance. A site I do not frequent myself. And we build it all in. I think it's awesome to have extensions if you're allowed. Can't have them on Chrome and Android. If you have the Safari ad blocker, content blocking extensions that have an app install model, that can be more convenient. But it's still this other mouth to feed. Most users don't really want to figure out how to use these. They don't always play nice together. The content blocking API is somewhat limited on Safari, though I'm sure Apple's making it awesome in future releases. So we put it all in one box, make it easy to use, and test it. And that's important because if you don't QA this, as anybody who's used an ad blocking extension knows, you often end up with a sort of malfunctioning site or a white screen of death, or a site that says, hey, you're using an ad blocker, we hate you. Turn it off, or subscribe, or die. And sites that do that generally lose traffic. It's not a good thing to do, but it happens. In Brave, we actually engineer around that kind of junk. We figure out ways to fake them out. They're pretty much blue-pilled in our matrix. There was a paper from Princeton on this recently that talked about how it was a little bit hyped. It said the end of the ad blocker wars. It said the browser ultimately can figure out what's an ad and what's not, because humans can detect ads, often by their opt-out widgetry. If you can do that as a human, then machine learning or even simple OCR techniques can do it. You can block ads in the browser. They had a more clever thing in the paper, I thought, which was using the isolated worlds feature in Chromium to make two worlds, one for the content to load so that the publisher's anti-ad blocker detector can think, oh, no ad blocking here, nothing to do to tell the user to go away. And in the other world, ad blocking happens. Sorry, publishers, you cannot count on being able to detect ad blockers. And Brave is proof of that. We're doing more because ad blocking and tracking protection are good defensive measures, entirely justified, moral, and ethical within your rights as a web user. The web was designed to allow mix and match, screen readers, ad blocking. No DRM for ads, please. Could happen. DRM's coming into W3C. But we added a micro donation system as well. It's in ending its first beta. We're going to do a second beta that's even better with Stripe as a partner. So you can just pledge whatever you want, $5, $7.50, $10, $20 a month to be automatically apportioned among sites you like. You don't have to think about it until near the end of a 30-day uptime period. Then you can sort of say, I don't want that site. But it's all based on private, on-device, in your browser-only analytics. Not on any site, not on Brave servers. And at the end of 30 days, your donations go through a zero-knowledge proof protocol across a VPN. So we don't see the sites. Nobody sees the sites. But the money piles up in pro rata shares among the websites. We've onboarded over 157, I think, sites so far, with 150 or more in the queue. You go to publishers.brave.com if you want to collect your money. As we grow, there's more money. Some of the sites are really big. We'll announce their names soon. We're making sure that they are OK with that. And going forward, we'll have it be easy for people to say, I want to be listed as a publisher who's paid through this mechanism. That is something that I'm excited about, but I don't expect it to really go all the way in replacing ad revenue. Patreon is an interesting site that's done well, but you have to sign up as a creator there to get patronized through Patreon. So we're adding something to our micropayments, microdonation system that's called pinned donations. You can see the orange pins there. So you can actually sort of say, I want to commit 10% of my monthly budget to a site, whether I go there or not, whether I browse there or not. And again, it's through a zero-knowledge proof protocol. There is no link back. This has interesting properties. Anonymity has consequences. You can't get a refund. You're committing a small amount of change to sites you like. I think people are willing to do this, considering how much the tracking costs them in their data plan and how much we save there. Sprinkling some back in an irrevocable way among your top sites seems like a fair deal. But again, will donations be enough? Maybe not. So we're looking at blockchain-based digital advertising. And this isn't just blockchain hype. We really do see a need for aggregate attestation through something like a blockchain, a neutral, decentralized proof system, because there's so much fraud and hype in ad tech. This is a famous picture from Terry Kawaja's Luma Partners. It's called a Lumascape diagram. It shows the ecosystem that evolved since the cross-site image, that's Mark Andreessen's fault, and Eric Bina. The cookie, Luma and Tuli, but Lou had a good idea for the cookie. It was for first-party logging, credential caching, not for third-party tracking, but just between the image, which you could load from your friend's cat server, and the cookie, you had third-party tracking, because every request can send and return a cookie, and that means that you can have an image that's on 2 sites from a third site, track your navigation to those 2 first-party sites. And that's exactly how trackers worked at first. They even call them pixels still, even though they don't use images, they use scripts. Because when I did JavaScript and then added script source equal in 96, it just added fuel to the fire. So this whole crazy ecosystem, and you can see everybody's in there, it is like a parasite-infested swamp. And it's full of hype and fraud and measurement error, measurement fraud, innocent errors. No, who knows? Intentions don't matter. It's really the consequences of this, which is there's too much money taken out by the middle players, too many entry points for fraud and malware, which has happened, malvertisement. Estimates of 16 billion being wasted in fraud this year. So we want to clean that up. And part of that is, like I said, using the blockchain for what it's good at, which is recording aggregate results and sort of trends, so that you can have no fraud, you can have no trusted intermediary who might be, in some bad part of the world, might be a fraud actor. And we really do want to help these publishers who are suffering this revenue loss that has been going on for, especially in the last 15 or so years. You can see it on this chart. I know on Twitter someone did a chart that showed Google and Facebook revenue, which was rising in a blue line to sort of complement that cliff dive at the end there. That's an issue we see. Not to pick on Google and Facebook, I think, in terms of web standards, Google and Apple have to cooperate more. But Facebook is doing a bunch of generative JavaScript work, and that's awesome. But they're also, doing an ad business. And that means that they're sort of the junior partner in the new duopoly. People thought, oh, it would be Windows all over again. The smartphone would get taken over by Microsoft. I remember talking to Andy Rubin in 2006 when he was starting Android, and that was the fear. And it's different. History rhymes, but it does not repeat. And we now have this situation where even with that crazy Lumascape full of middle players and parasites and third parties and seventh parties, Google and Facebook are the Pareto power law, winners. And this is taking a lot of money out, and it's putting a lot of tracking data into those giant walled gardens. And then those walled gardens are saying to the publishers, especially the newspapers, come and put your news content in our garden. It's nice here. We trim the hedges and we kill the pests. And the problem, I think, for the publishers is they lose control of their brand. Their news content gets broken down into little commodity pieces, and they kind of die. They continue to go off that cliff. So can we do something with blockchain-based digital advertising? We have plans. We're launching a token on Ethereum. Pretty excited about this. This is a unit of account, medium of exchange. It's something that we actually want to stake users with. We're doing it because you can't really claw back money for the user in this ad tech system. And if you go ask for it, people will laugh at you. The middle players already take big cuts. The publisher is getting less and less. So we're remonetizing the user by creating a new token. The token also allows us to use zero-knowledge proofs on the Ethereum blockchain eventually. Initially, we have them in Brave. And we will be working on this in sort of a space program sense. We're in the current Mercury Redstone suborbital phase, but I think we will get to a decentralized, transparent ad exchange that has anonymity, has micro-donations, has other properties that you want from such a system, and does not require a giant walled garden central trusted party. So that's the basic attention token. That's part of our attempt to make up for the loss of advertising revenue, such as it is. And I'll stop there to avoid taking more time. Thanks.
Thank you so much. We're all clapping. You can go ahead and stop recording your screen as well too. Thank you. And feel free to send me those slides and the recording. I'm really excited about the things you're doing. I know we had a conversation about a month ago, and I think it's voices like that, like yours, which are going to help the industry move forward. And this is what I love about this.JavaScript too, that we're able to sort of get little sound bites from everybody and see what is happening with everybody, and actually, like, hopefully these conversations and you guys seeing what everybody else is working on is going to inspire. So with that, wanted to go ahead and introduce Nolan Lawson from Microsoft Edge. And we're all clapping for you, Nolan. Don't be scared.
No, oh no. Sorry, the silence can be kind of terrifying. Can everyone hear me? Is that okay? Is my microphone coming in?
Yes, and then make sure to record your screen as well, please.
Yes, I started up QuickTime. I was very sure to do that. Now let's just do the screen sharing thing. Screen share, entire screen. All right, you guys are gonna see the whole thing, all my secrets. Okay, is that good? Can you?
Yes.
Okay.
Mm-hmm.
Cool. All right. Okay, so let's get started. Okay, so I've got 10 minutes, right? So I'm gonna make this, try to make this go fast. Okay, so I'm Nolan Lawson. I'm a program manager at Microsoft Edge. And basically what I'm gonna do in this talk is I'm gonna talk about, we're gonna go back into the salt mines, as Brendan said, and talk a little bit about the guts of the browser. I'm gonna talk about where Edge, Microsoft Edge has been the past couple years or so, and where we're going, where we're at right now. So I'm gonna cover a few different topics. First off, what is Microsoft Edge? You may be surprised, but a lot of people actually don't kind of know what Microsoft Edge is, so I kind of lead with this. And then second up, interoperability and fundamentals, kind of our main focus since the genesis of Edge. Edge 15, the new version that we just shipped, actually just a few weeks ago. What's new in that version? And then most importantly, 2017, what we're planning on doing this year, and how you all, web developers and designers, can get involved and help shape our future. So, first off, so what is Microsoft Edge? Okay, so it is our new browser. So Internet Explorer is in Windows 10, but it's kind of hidden. Like, you have to kind of search for it to find it. Microsoft Edge is the new default browser. It's the one we want people to use. IE 11 is the last version of IE ever. It's still supported, but it's not being actively developed. So basically, just gets security patches and whatnot. Microsoft Edge is the path forward for us. So the basic path where we came from is around 2014. We forked the Trident engine in IE and just removed all the legacy stuff, all the stuff that web developers hated, like doc modes and ActiveX and all stuff. Just ripped that all out, announced a new project, Project Spartan, released it as Microsoft Edge 12. And then over time, we released Edge 13, and then announced that Internet Explorer was going into maintenance mode, and then Edge 14. And then most recently, just like 10 days ago now, we released the current version, which is Edge 15. So a lot of people know that we do this release cycle. You know, right now I think we recently announced that we're on this cadence where we're releasing twice a year pretty predictably, along with Windows. But on top of that, a lot of people don't know this. You can actually get preview releases of Edge pretty easily. You just sign up for this thing called the Windows Insider Program. You don't even need an appmicrosoft.com account to do this. Anyone in the world can do this. And then you can actually see previews of Edge on both this, what we call this fast ring or the slow ring. You can get updates as quickly as once a week or once every 2 weeks. And then we've also got this other new option that we just actually announced, which is that we're partnering with Browser Stack. So if you want to easily test Edge, like you're not on Windows, and you want to easily test Edge, you can sign up to Browser Stack and you can test the current version of Edge, last version of Edge, and they should now have the beta release of Edge in there as well. So pretty easy way to test Microsoft Edge. So if you're not aware of all this stuff, it's all out there and it's all free. So kind of taking a step back, like with what we're trying to do with Edge, our focus from the beginning has kind of been on interoperability and fundamentals. So what does that mean? Like, why is that our primary objective? Well, the main idea is that we're trying to do well on things like, say, HTML5 tests. So these are various HTML5 test scores for different browsers. I took the score from the most recent releases of all the various browsers. And you can see that we are just a hair behind Firefox on this. There was like one glorious shining moment where we released Edge 14 and we were ahead of Firefox, and then Firefox like released their new version like that day or the day after, and I swear it was just to deny us the satisfaction. I don't know, but it's okay, Potch, I forgive you. This is the kind of browser competition that we want to see, right? We want to see browsers competing on the stuff that makes web developers and designers, makes their lives easier. We want to avoid the situation where you test it in Chrome, works great. You test it in Firefox, works great. And then you open an IE and you're like, oh my God, why does IE have to ruin my day, right? So our goal with Edge is to make it so that does not happen anymore. So on that note, this is all the new stuff that we are shipping in Edge 15, which just got released. So this is also called the Windows 10 Creators Update. That's kind of the marketing name for it. But basically, you can call it Edge 15. We shipped a lot of cool new stuff in there. We got all of ES 2015, aka ES6, except the tail call optimization. Sorry, tail call optimization fans. We got all of ES 2016, which is like 2 features, but hey, we got it. WebRTC 1.0, we had a thing called ORTC, and we're still pushing forward on that, but a lot of people wanted WebRTC for various interoperability reasons, so we implemented it. Payment Request API, Poch and Addy mentioned this one as well. We are super excited about this one as well. That is in there. CSP 2.0, really, really good for security. CSS variables, lots of people love CSS variables. That's in there now. WebVR, yeah, so we're shipping our first version, initial release of WebVR. There should be some interesting announcements this year from Windows Holographic, some cool VR headsets. I could give you more details on this, but I would have to kill you. So just stay tuned. In 2017, there'll be some interesting announcement, I can assure you. Lots of other cool stuff in here. I'm not going to go through like every single line item one by one. If you want to just know what's new in Edge 15, now is the time to take a screenshot. I'll just give you an opportunity to take a screenshot right now. I'll take a sip of coffee. But this is all the cool stuff that we shipped. There's also some stuff behind flags. So if you want to go to about:flags, you can actually play around with some really experimental stuff like our experimental service workers implementation, shared array buffers, some cool stuff like that. We've also been working a lot on battery life. So I'm not going to play this whole video, but basically, if you run Edge against other browsers on other Windows browsers using a gamut of different tests, you will find that we do really, really well on battery life. And since I am build 4th and I'm after the Firefox and Chrome representatives, and you don't have an opportunity to refute me, I will say, yes, we have the best battery life on Windows. Test proven. So. And then looking forward, 2017. So what are our plans for the future? Well, kind of our major focus is going to be on service worker and related APIs. So service worker, background sync, push API. The other one is cache API. So that's kind of like our primary focus right now. The second big focus for us right now is DOM performance. Really want to make sure that Edge runs well on the modern web. It's becoming more and more important all the time as pages become more and more interactive, more hit the DOM APIs a lot more frequently. We're working on fixing our dev tools. So our F12 tools should be getting a lot better in 2017. PWAs, we are totally behind this effort, and we are working hard on all this implementations. And then also a lot of like CSS modernization, just kind of making sure that we're caught up with the other browsers on this one. So here's our 2017 roadmap. This is another good one if you want to just take a screenshot and know exactly what's coming down the pike. Basically, as I said, it's like a lot of work on service worker and related APIs. DOM performance, we're focusing very much on benchmarks like the speedometer benchmark, because, as I said, like this is just becoming more and more important as the web becomes more kind of heavily client side. So we're focusing a lot on that. We made some big improvements already in Edge 15. We've got some more improvements planned. Lots of new CSS features, object fit, object position. We're fixing grid. We actually, a lot of people don't know this, we actually created grid, like V1 of grid was shipped in like IE 10, it came out of Microsoft. But then like the planets kind of aligned and all the other browsers like released their update to grid like at the same time in like the same few weeks. And we're like, so now we have to update grid. But we were working on updating grid so we can get all the browsers up to the same level on that. Sticky positioning, lots of other cool stuff in here. Again, I'm not going to go through every single thing, so this is your screenshot opportunity. Most importantly, your suggestion here. So that is kind of the next part of the talk that I want to talk about. I want to talk about how you can influence the APIs that we decide to work on and our relative priorities for those things. So another thing we're trying to do with Edge is we're trying to be a little bit more open with the community, trying to make sure that we're not just going to go off the rails and implement and spend a lot of time to implement an API that then like nobody wants to use, that you all don't actually want to use. So we're trying to be a lot more open about this. So one thing we're doing, which I'm really excited about, is we're doing a lot more open source. So the browser itself obviously is not open source, but we've been like slowly open sourcing a lot of the components of it. So Chakra, the core JavaScript engine, went open source. Our WebGL renderer was open sourced as well. And then also all this work we're doing with like battery life and testing, like all those tests are completely open source, and we're happy to collaborate with other vendors on it. It's all available on GitHub, github.com/Microsoft Edge. That's the browser efficiency test and elevator projects. And then also, we're planning out in the open. So you can go to the site status.microsoftedge.com, and you can see all the APIs that we're working on and what we consider their priority to be, and the ones that we're like, not so gung-ho about. And most importantly, you can find links in there to this thing called user voice, where you can go and vote them up. And that actually is really, really important. That actually figures a lot into our planning process, like for us to kind of gauge like the level of web developer and designer enthusiasm about different APIs. So if you see something in there that's like not very highly voted up, and you're excited about it, then go in there, vote it up, get your friends to vote it up. It actually works. And then we also are opening up our bug tracker. So we have this issues.microsoftedge.com. You can go there and you can see all the open issues about Edge. You can file your own issue. You can see who it's assigned to and like whether the fix was shipped or not. And this actually like feeds directly into our actual bug trackers. Like you file a bug here and it will actually get triaged by someone. So we're trying to make filing issues a lot easier. And on that same note, some people don't actually even want to go to a website and have to log in and then file the bug and include all the steps to reproduce and exactly which version of Edge and all that stuff. And by the way, that is incredibly useful. If you've never filed a bug on a browser vendor, you absolutely should. All the browser vendors have public bug trackers. Go and like familiarize yourself with them. It's a really, really good way to contribute back to the web platform. But on that note, we're trying to make it even easier to file bugs in Edge. So actually, we have this new thing called Edge Bug, where this is true. This is literally how you can file a bug on Edge. Just use the hashtag Edge Bug and include a link to a JS bin or a code pen or whatever, and it actually goes into the same like pipeline as our other issue tracker. So this is the easiest way to file a bug on Edge. So just use hashtag Edge Bug. So that's all I got. So thank you for listening to me. And if you want to get in touch with us, we've got microsoftedge.com, lots of different links there. You can also follow us on Twitter at MSEdgeDev. So thank you very much.
Thank you. What about the Microsoft Edge? Not that one? MS Edge Dev?
MSEdgeDev, that's right, yeah.
Exciting. Cool. So next up we have, who is going next anyways? It's going to be Sean. Sean Larkin from Webpack is going to be speaking about Webpack. So Sean, make sure to record your screen.
Let's get it set up. And press the recording. There we go. One more time. I think we're good. Cool. All right. Well, how's it going, guys? What's up? Let me get my share screen going, and we'll take a look at some slides, and got some fun, exciting updates to give you all. All right, excellent. And everybody can see that okay. All right, excellent. Can you guys hear me all right? Yes, maybe nods, thumbs up, whatever. Okay,
yes,
cool.
We can hear you.
Let's do this. All right, so what's up, guys? Yeah, my name is Sean Larkin. And so, the title, this is Webpack 2 and beyond, but the This.js special April edition. So yeah, my name is Sean Larkin. I'm a UX developer for Mutual of Omaha Insurance Company in Omaha, Nebraska. But you might know me as a maintainer and kind of filling the role as developer advocate for the Webpack open source organization. But I also spend time on the Angular CLI team and just kind of an evangelist for open source sustainability. So we're kind of working our way out of the salt mines into the JS renaissance. So yeah, just a shout out to Mutual of Omaha. So if you guys don't know where Nebraska is, I think most people tend to think it's like right about where this area is, but really we're right there. Yeah, so thanks to them for always being behind me and supporting this kind of stuff. So some other things I've been extremely interested in is just building communities and contributors around the ecosystems of JavaScript and trying to encourage other people to get excited about it. And so if you guys want to find me, you can always find me at the Larkin at all those links. And then you can ask me anything at my GitHub, the Larkin/AMA. It could be work, life, whatever, doesn't matter. And so, like I said, we're going to talk about Webpack today. And I can't make an assumption of who. Usually I have people raise their hands and say, do you know what Webpack is? So I'll just give you the half elevator pitch. So Webpack is a module bundler. And what does that even mean? So a module bundler, in its most simple, bare bones explanation, is that it lets you write modules, compiles them so they can work in the browser. There's all sorts of different module types, but I assume that most of you guys actually know what Webpack is in this case. But I want to talk a little bit more about what's kind of going on for our community and what kind of updates. What have we been doing since, let's see, since Webpack 2. And we released Webpack 2 just a couple months ago. So it was not only just about shipping Webpack 2 and getting people off beta, but it was more than that. It was about the community. And so the number one feature that was requested was documentation. So if you have not been out to our documentation, go to webpack.js.org and take a look at it. We think that this is the number one feature that shipped with Webpack 2. But it was also kind of like a brand revitalization for us. Before I joined the core team, we didn't have a core team. And we didn't do, we weren't having a medium for apparel or anything like that. And so this is kind of our way to be able to, we're starting off on the right foot and being able to put you at the center of our development. So what have we been up to, Sean? What are we doing? So, the first thing is that we joined Open Collective, which is an open donation platform, in, I believe, October. And since then, we've raised through sponsorships and backers together an estimated budget of $83,000 a year. And so to all those people out there who believe in us, and you guys are now stakeholders and shareholders of our product, and have an equal opportunity now to collect a part of the share that is in this platform, and even to so much that the original author, Tobias Koppers of Webpack, is now working full-time on the product because of these contributions. And this is a huge step for us, and not only a milestone for open source, but for a product that has never been backed by a single large company like Angular or React or any other tooling. It is all about the people who use it and the people who support it. And so we see this as a really significant milestone for us. But some other things that we've been doing is just, each of the maintainers kind of have a special niche role. And so one of the things that I'm in charge of is, developer relations, communications, and evangelism. And so we've been kind of upping our game when it comes to publications. So if you haven't taken a look at our Medium publication, go ahead and check it out. Not only is it going to contain Tobias's logbook for his full-time freelancing of Webpack, but it also is going to contain a whole bunch of different tips and tricks and partner articles from people like Rich Harris, from Rollup, and even Addy has. And myself and Juho Vepselainen, two maintainers, are doing speaking across the country, across the world right now as we speak. So you can take a look at the Survive.js tour and see where Juho is traveling in Europe. And you can always follow me on Twitter, and I'll keep you up to date. Here's Juho. But on top of that, it's actually kind of nice that I went after basically all the browser teams speaking. And that's because, every single one of them mentioned features that to us are some of our main, our key initiatives to help them accomplish it in one way or another. So whether it be helping drive the web forward with progressive web apps and helping create trivial, ways of accomplishing purple through Webpack. We also worked, with the Chrome team, as well as people like Jason Miller, the author of Preact, and helped them along the way to provide support to be able to ship and showcase these progressive web apps. And then working with Addy to come up with, a great idea for being able to warn people that, hey, you're shipping too much code. Let's at least try and tail it back a little bit. And here are some tips that can help you. Now, on top of that, we're doing more than just working, with the browser vendors, but we're also having to, this has been a huge growth process for us. And so, looking back a year from, roughly today, in April of 2016, we had 500,000 monthly downloads. And as you can see to the far right, we now have over 5 million monthly downloads for Webpack. And so it's been an incredible and kind of inspiring year of growth that we've seen. And not only that, but our community has grown. You can kind of see here in the same way, our contributions have exploded in 2017. And that's some of our initiatives are being able to provide a huge rich ecosystem and a way for them to contribute to what some originally thought was a black box tool. And not only that, but maintenance of these contributions. Now that Tobias is, or Sokra as he's calling GitHub, is full-time, we have the opportunity to be able to better triage and better accept contributions from people in the community. And so what else? Well, there are some other repos that we've added to our organization that you might have noticed or stumbled across. And so the first one was that we moved all of our loaders and plugins from the Webpack organization out to a separate organization called Webpack Contrib. And the reason behind this was, one, we were running out of Travis CI available queues. But also, we wanted to have a set of standards across the board that allowed us to be able to apply for every loader and every plugin. We believe that the experience should be the same across the board, but it should also be easily accessible and maintainable by a group of individuals. And so we took a few members of our contributor team, and they are now maintainers of Webpack Contrib. The second one on this list is the Webpack CLI, and you might say, Sean, we already have a CLI. What are you talking about? Well, so we believe and we recognize that the community, has voiced their opinion that sometimes Webpack is not the easiest to get started with, and we want to be able to come up with a way that not only it's easy to migrate through breaking changes, but also to apply best practices, quick and easy setups. That are unobtrusive, but allow you to customize to your workflow and your behavior. We did the Webpack CLI, and it's still in alpha and beta for some of its features, but we've hit the ground running on it, and we have a dedicated team who's worked on not only a migration feature to upgrade from Webpack 1 to Webpack 2, but also an entire add-on system that allows people like library authors or framework authors to create add-ons that are have their stamp of approval and a best practice for setting up Webpack. And then we also moved in an awesome community, awesome list called Awesome Webpack. And so this is being updated at least weekly, adding all of the incredible videos and resources that we are seeing from our community. And then finally, right now we stand at Webpack 2.4, I believe 1, but this is our latest minor Semver. So 2.4, I wanted to just share a couple of features. If you haven't updated to it, we encourage you to do so. But this adds some additional features that allow people to code split, but then support features like server-side rendering, or handling failed promises or error callbacks if they're still using require ensure. Now what? What are you guys doing right now, Sean? So there's some incredibly exciting stuff that I want to talk about. So the first thing is one of the big features that everybody would like to have Webpack add, and that is the rollup style scope hoisting. And so right now, this is the #1 voted feature on our voting page, and it is what we are actively working on as we speak. And on top of that, there is better tree shaking. So we've been pairing with the Clojure compiler team and a few of their top contributors to find a better, more organic integration between Webpack and Clojure compiler. And then also taking some incredible plugins from the community, like hard source Webpack plugin, and implementing them natively. This is a little bit lower on our list, but still one of the top 5 on our voting board. And so we recognize this and want to be able to start experimenting with it. And then just general TypeScript integration and support for tree shaking, for compilation, for speed, etc. In a perfect world, we would love to see TypeScript as a first-class citizen, but there's a lot involved to make that happen. And so this is something on our list, and it's definitely important to us. And yeah, like I said, take a look at this voting page right here. It's webpack.js.org/vote. You can see that those 4 items are exactly the 4 items that I just mentioned. The point is that because you guys are shareholders, the people who use and submit bugs and file issues, you guys are all in control of voting for what features come first, and especially those who are sponsors and backers. So if you haven't checked this page out, go ahead and take a look. Obviously, you can see there's an epic battle between scope hoisting and persistent caching. And then another feature that I wanted to talk about, and coming back to how we're working with different browsers, is we started talking with the Firefox team about WebAssembly integration. I'll post the slides afterwards, but you can take a look at the initial proposal. But we believe that WebAssembly should be a first-class module type in Webpack, and that it should be supported. And so the benefits that come with this is allowing us to do something maybe as simple as this. There is no reason why a web developer should ever have to worry about having a shared memory buffer, or having to write 14 lines of boilerplate code, or worrying about compiling it to a WebAssembly module, or worry if they're doing it correctly. The 2-part step is that we believe that you should be able to directly import any language that can compile to WebAssembly, pass it through a loader, and have it return a WebAssembly module so that you can use it just like JavaScript. It should not be just limited to framework authors or gaming vendors. If you're a financial institution and you need to do heavy calculations on the front script, then you should be able to do so. And so we think that this first-class integration not only is going to allow the adoption of WebAssembly, which we believe is, the future of the web, to skyrocket, but we also believe that it's going to make it easier and put it in the hands of people who may not be able to use it in the state that it is today. And so you can also take a look at the Webpack CLI repo. I know I talked about it before, but go to webpack/webpack-CLI, and right now Evan Stensberg is working on the add-on system, and we're looking for people to help create unit tests and add-on ideas. And just in general, use Webpack too. If you aren't there already, jump on the CLI and try and use the migrate feature. Or you can reach out to any of us at any time. And then in addition, you can go to opencollective.com/webpack and reach out to us by becoming a sponsor or backer. Or if you can't, maybe convince your boss. We also have some special VIP services, so you can always email webpack@opencollective.com. Help shape our future by being a backer and a sponsor, or in what I like to consider it's a shareholder. You guys are the community, and the best part is that our top contributors, aside from the core team itself, spends freely for the work that they put into our organization and contributions. So we end up paying out more of the money to those who aid us in being able to make our community rich and vibrant than we do ourselves. So, I don't want to make it run too long, but you can reach me at the Larkin, and honestly, tweet me any feedback that you want, or if you have questions about WebAssembly, or if you want to get involved. One of the biggest needs that we have right now as an organization is just people who are willing to learn and having people who want to help. And you can always tweet #Webpack, and I will always read those tweets. So I spend about 4 or 5 hours a day on them. But yeah, does anybody have any questions or anything like that?
That's awesome. I'm excited to see all the stuff with Webpack and WebAssembly because I've been wanting to play around with WebAssembly. But
Yes. Oh, I forgot to mention, we did just submit our Mozilla open source software grant for the feature. So we're asking a large sum of money to help support all the maintainers to implement this feature.
And I'm about to post Webpack contributor days.
That's right.
So Q1 of next year, we'll have that, which will be exciting. Yeah, and also I think this is a really great way to, I think you're setting a really good example for other open source projects. Some things like, for example, I really want to fix the RxJS docs, but I just am not going to spend 40 hours of my free time doing it. I just can't. 40 hours a week, yeah. So I think this is a very sustainable, better way to do things. And hopefully that means that Webpack will be around for a long time.
We hope so.
Yeah, very cool. Okay, so next up we have, by the way, you can stop recording your screen and whatnot. Next up we have Sashko from Apollo GraphQL talking about updates there.
Hey, all right, clear my throat. Let's set up this screen recording thing here.
Yay.
Can you guys all hear me fine?
Yes, we can.
Okay. Let's see, screen recording. Yep. All right. Okay, and then I have to share my screen here as well. Hold on. I have broken something with QuickTime. Let's try again. Okay, there we go. Now to share the screen. Perfect. All right. So yeah, like Tracy mentioned, I'm Sashko. I'm from the Apollo team, and we're a team that works a lot with the community on a lot of GraphQL tools and in general on growing the GraphQL ecosystem. So like everyone else who's presented, first I want to just start off and give a super quick intro about what GraphQL is in the first place. And the one sentence summary is that it's a query language for your API. So most of the APIs people are using today, when they're not using GraphQL, is they're calling endpoints. And in some sense, with those endpoints, you can think of the query language as query parameters, path segments, the domain, stuff like that. So what GraphQL does is it specifies, instead of that, a query language to define what data you're looking for. Some of its main features are that it's self-documenting, so you can easily organize your data and know what's available. Because you select exactly the fields you need with the query language, you can only fetch the data you need, so you can eliminate what we call overfetching. You can also request multiple resources, even nested ones at the same time, so you can avoid request waterfalls like you might see in your network tab all the time. And the best part for me is that there's this super extensive community that I'll get into in a minute about client libraries, server libraries, all kinds of developer tools to help make developing with GraphQL really awesome. So the easiest way to understand what GraphQL is to see it for yourself. So I'm gonna do like a 2-second demo here. So let's make this bigger. Computer is getting crushed by all these screen recording tools. Okay, so zoom in a little bit. Basically here you see on the left a GraphQL query, and on the right you see a GraphQL result. One of the primary features that you can see is that the result has the exact same shape of the query. And then just the one thing I want to demonstrate here is that you can add additional fields and see those show up in the result, right? So this is an example app we've built that has like a public interface to this great tool that you can use to write queries. So for example, we can say, okay, we want to get the stars, and you can see because it's self-documenting, it auto-completes right there in the tool. So we hit enter to add that field in there. We click play, and then we're going to see that extra field show up on the right. So now you can see in the result, we now have the stars for all those repositories that we were fetching. All right, so we've seen a little bit about what it's like to use GraphQL. You can extrapolate from that. So what else can we learn about it? So like I said, the most important part is that it's not a library or a product. It's not a repository on GitHub. It's not a particular service. It's a specification currently maintained by Facebook. They originally introduced it in 2015. And a bunch of people work together on that and all the tools. Like I said, it provides a schema for your entire set of data, and also that query language that I was showing that lets you retrieve that data really easily. And another really important thing that people don't always realize is that it's incrementally adoptable. So you can use with virtually any kind of client or server-side architecture. Anywhere where you can make an HTTP request or even any other protocol, you can use GraphQL to describe the data you're looking for. And in 2017, this presentation is kind of like the current state of GraphQL. It's really, really heating up. All kinds of organizations are starting to adopt it, not only for their internal APIs, but even some are starting for their public API. Like GitHub was one of the trailblazers in September of last year. They released the first ever widely used public GraphQL API. And some other people are going to follow with that as well. So you'll be able to get public data in a much more convenient way. So like I said, it's a specification. So the biggest news in the community is always specification updates. And the newest thing in GraphQL right now are GraphQL subscriptions. So the spec usually comes out on a schedule of about every 6 months. And the last one was in October. So we're expecting a new release of the specification in April. And hopefully one of the things that's going to be in there is this concept of GraphQL subscriptions. So GraphQL originally was released with queries for fetching data, dating that data. And what subscriptions do is they let you also have the ability to get a real-time stream of data. So basically, you take a server-side pub subsystem or something similar like that, and you can push those messages to the client. And because it's GraphQL, you can select exactly what information you want about every single message. So you can get that pub sub message, attach additional data to it, stuff like that. So one interesting tidbit here is people often ask, what's the difference between subscriptions and something like live queries? Because they're both ways to think about real-time data. And I think live queries are something a little bit more like Firebase, for example, where you select a set of data and you expect to get notified whenever that data changes. You can think of it as just like really optimized polling. But subscriptions, the thing that's landing in GraphQL, is a little bit different. It's a more limited but easier to manage approach, which specifically talks about events and pushing those messages to the client. So that's the biggest news in the GraphQL specification right now. And let's get into some of the open source tools that people are working on. So probably the most important part of every GraphQL architecture that you can't really get by without is a GraphQL server. And just like you can build a REST API in any server-side technology, you can do the same with GraphQL. So there's server libraries available in pretty much every popular server-side technology and framework, Ruby, Rails, Node, all of that great stuff. And you guys can find those on graphql.org/code. That's where a central place where people can list their various libraries. And the new news in that department is Walmart Labs recently, just a few weeks ago, announced their server-side GraphQL implementation that they're using for products like Sam's Club or other websites, which is implemented in Clojure. So if you want to be using the same thing that Walmart is using for some of their APIs, you can check that out. And then the other dimension of GraphQL, once this next slide loads, computer is really, there we go. The other dimension is clients. So like I said, you can fetch GraphQL from anywhere where you can just hit an HTTP endpoint. But you can get some benefits if you use a more sophisticated client that does some caching for you. Because with GraphQL, you can fetch all these different queries with different shapes of results. Basic HTTP caching that caches on a per request basis doesn't give you everything you need. And you can learn a little bit more about that in the documentation of these various clients. But the really big news right now is just in the last month or so, the two most major GraphQL client libraries for JavaScript are both releasing 1.0 releases. So Apollo client is the one that I actually have spent a lot of time working on, named Apollo, just like the team that I'm on. And it works with all different JavaScript technologies like React, Angular, Next.js, Redux, and we're always trying to make it more modular and more compatible. And it's also super community-oriented and flexible. And currently, it happens to be the most popular GraphQL client for JavaScript. Relay is a GraphQL client that was announced by Facebook at the same time as they released GraphQL in the first place, almost a year and a half ago. And recently, it underwent almost complete rewrite to become a lot faster and simpler. And it has a more opinionated architecture that fits well with how Facebook does things internally. So I think it's super awesome that even in some, GraphQL has always felt niche in the past, but I think now it's really becoming like a mainstream thing, and you can see that just by the diversity of tools that are available there. And I know that I'm here at this event called This.JavaScript, but I'd be remiss not to mention native mobile clients, because when you have an API technology, you want to make sure that you can access that from any of your clients or any of your API consumers. So libraries that not only let you fetch GraphQL queries easily from Swift on iOS or Java on Android, but they also do code generation, because GraphQL is strongly typed and it has types for all data in your schema. And so is the programming language, which is a little bit different from JavaScript. And so you can get a really nice auto-completion and validation in your editor and stuff like that. And so you guys can check those out on GitHub. And one thing I'm really, really excited about, things that we're going to be working on pretty soon, is an opportunity to integrate that with the JavaScript client. So for example, if you're using React Native or a similar architecture where you have both JavaScript code and native code at once, you can actually share data between those two clients and have parts of your app implemented fully in native and parts of your app implemented in React or JavaScript, and maybe fetch data in the background or share the cache data, stuff like that. And working with some great organizations like New York Times, Shopify, and Airbnb that you saw on that slide up front of who's using GraphQL. And perhaps one of the most exciting things about GraphQL, like the tool that I showed you, is developer tools, because you have this not only a strongly typed API, but you have this nice query language to interact with it that gives you a whole new space of developer tools to explore for APIs and data fetching. So the tool that I showed you, which is kind of like an auto-completing query editor, is called GraphQL, and it was one of the first awesome GraphQL tools that was released almost right after GraphQL itself was released. And that's something almost everybody uses to interact with their API, and it means you don't need to open up a terminal and type curl or anything of that nature. Then there are also a lot of really great tools coming out around query validation, extracting those queries from your code, something we call persisted queries, which is about telling your server ahead of time what queries are going to happen, because GraphQL seems like it can be quite dynamic. But if you can tell the server ahead of time, you can make sure people aren't sending you queries that you don't expect. And one other thing that we released late last year that we're really excited about are a set of Chrome dev tools for Apollo client that actually look inside the client-side store or the cache, much like Redux dev tools or similar, and they show you what data has been fetched, what's in your cache, what is being sent over the network, things like that. And the new thing in this space, which I'm really, really excited about, is a new project from Facebook that everyone in the community is working together on called the GraphQL Language Service. And the goal there is to give you the same experience you get in this graphical tool, which is like a standalone web IDE type thing. But you can get that right inside your normal code editor IDE. So you can open up IntelliJ or Visual Studio Code or Atom or whatever you like to use. You can start typing GraphQL queries in there right in your code, and it'll validate it for you, auto-complete it for you. So you really never have to go and look at API docs like ever again. And that's great, because I really don't like looking at API docs. I'm sure most people don't either. So that's pretty much the state of the tools for the stuff. And I think, like I said, the most important thing about GraphQL is the community. And there's also a lot of great community events that happened recently that are coming up. So there's already been the first GraphQL conference where over 350 developers met up in San Francisco. It's called GraphQL Summit. You guys can check out all the talks at graphqlsummit.com. They're all there in a nice grid. And there's actually going to be another one this October, so it's going to be one every year in San Francisco. For Apollo, we had an event very recently called Apollo Day. And then another really big piece of news this week was that Shopify announced their public GraphQL API. And you can check that out if you go to that URL there, where they have documentation and examples and even example apps that you can download. And one last thing, well, probably the most important thing that I want to mention is that there's another big GraphQL conference coming up in Europe, which is going to be in Berlin on May 21st. And you can still get tickets to that at graphqleurope.org. There are going to be speakers from all kinds of organizations using GraphQL in production. So you should definitely check that out if that interests you. So another thing I think is important about an ecosystem like this is that there's validation that people are really investing in the technology and building their business around it. So Apollo has a product that gives you some server insights, regardless of what server technology you're using. There are also a lot of products that help you build your GraphQL server, like GraphQL, which integrates nicely with Lambda, or Scaffold, that helps you build integrations with services like Slack and similar. And GraphCMS as well, which is like a CMS akin to WordPress or similar, but it's headless and lets you define the schema for your data. So I think that's really cool, and I'm excited to see more companies jump on board and start building products targeted at developers using GraphQL. So if that all sounds really exciting, it's exciting to me to see so many different tools and products and community events. Here's a whole list of different resources you can check out. The most important one is always graphql.org. That's the homepage of the whole community. There's a great tutorial you can go to try out GraphQL in the first place at learngraphql.com. There's some Slack teams that you can join that have some really helpful people to answer questions and have discussions. We have a blog where we post at least twice a week about different topics in the GraphQL community, not just stuff about Apollo, but stuff about everything happening in GraphQL, and then also some other community resources that have regular content that helps you follow along with what's going on. So just like Sean Larkin was saying about Webpack, I think GraphQL is a community effort. There's so many different server technologies, client technologies, different needs for different organizations. And I really think that GraphQL is going to be one of the biggest ways that people are going to be fetching their data and exposing their APIs in the coming years. So we need everyone's help to make that a reality and bring this next generation here. So please just get involved, go to any of those resources, and reach out and start contributing. So thanks.
Awesome. Thank you so much. You can go ahead and stop recording now.
All right.
So we are going to be reconvening on May 12th, Friday, May 12th at 9 a.m. So for those of you guys who are watching this, this is a great opportunity to share the recording with your team. Maybe watch it during a lunch or something like that. And that you guys might have, what's blocking you guys in the different browsers, or different ideas that you might want to discuss as well. You can follow these guys again all on Twitter, and you can follow this.media on Twitter. If you just at this.media, then all of their Twitter handles will be there as well. Do you guys have any last words? No?
No, thank you for putting this together. Awesome.
Yes,
Thank
thank
you.
you very
Yeah, it was my pleasure. It was really wonderful. And we'll talk to you guys in just a month or so. Thanks again, everyone, for watching.
Always been on Webpack.
That's right. Yeah.
Right.
Bye.
Bye.